Good morning, good evening, good afternoon, and good night. I said that out of order. Today's functional groups are carboxylic acid, oh my god, my handwriting is not great today, and esters, but we're going to start off with carboxylic acids. These are super important because you see them in fatty acids in your food. They act as weak acids. They have an alkane chain, a carbonyl carbon, and a phenol group. Phenol being, they got the alcohol going on. They have a hydroxy group. So because of the oxygen in the hydroxy group, these carboxylic acids are soluble in water. They participate in hydrogen bonding. They are very water soluble, and they also have very high boiling points. And the more carbons they have, the higher the boiling point becomes because more bonds to break, as we have seen in the past. So going back to this hydrogen bonding, something unique about them is that they can hydrogen bond with other carboxylic acids, and basically with themselves, but not actually themselves, if you catch my drift. With like the same thing. So see here we have the same kind of carboxylic acid. We see 1, 2, 3, 4. 4 carbons. Remember that the prefix for 4 is bute. And we got alkane chains, butane, oic acid. Same on both sides. And because we have 2 of the same carboxylic acids hydrogen bonding, this is called a dimer. So when you are naming these salts, you're going to want to put the name of the metal or your salt part first. So here we got sodium. Sodium is going to come first in the name. And then the name of the carboxylic acid. So ethanoic acid. Except because it's a salt, we're going to change that last part to OH. So this is sodium ethanoate. If instead we had, instead of that ethene, we had, say, a benzene ring, with that carboxylic acid group, the carboxylic salt thing going on, that is going to be sodium benzoate. These salts are solid at room temperature. They're like salts. They're like salts. They have the same physical appearance. And they're also water soluble. And they are used commonly to control pH. I say this for all of the reactions, but this one is especially important. It's called esterification. That is when you take again, we're going to use super simple examples, a carboxylic acid and an alcohol, both got that eth thing going on, with an acid or acidic conditions, and heat to make your ester. What's important about the ester is that they have the carbonyl group here, and it's like an ether with a carbonyl group. This part right here, let me use a different color. to make it really pop. This bond right here is called the ester linkage. And how we're going to name this is it's going to be this side first, and then the alcohol side first, and then the carboxylic acid side second in the naming. So for example, we got ethyl, because you have that, it's 2 carbons. Then ethanoate, just like the salts. So the alcohol side first, and then the carboxylic acid. I'm just going to use Ca because I don't feel like writing that so many times. Esters are super common. They're used in artificial flavorings because they have sweet smells. They're used in like strawberry flavoring, wintergreen, a lot of different fruit flavorings for candy. Esterification happens all the time in your body for the digestion of fats and lipids. This reaction can also be undone when you have an ester and water to go back into carboxylic acid and alcohol. However, if instead of an ester and water, you have an ester and a base, so let's do that same one, the ethyl ethanoate. And if you remember, esterification is similar to the reaction we saw with alcohol. I need to go back to my notes. I have a really short-term memory, guys. For dehydration of alcohol becoming an ether. So it's really important to keep those two straight in your head and actually remember them. So if we had, here's the base we used from the previous example, and it's coming right back because if we have an ester and a base, that forms a carboxylate salt. And water, not water, I'm sorry, and your alcohol. It breaks them apart. So I think I was pretty straightforward on this one, actually. That concludes carboxylic acids and esters. Next, we're going to move on to two different functional groups. They're going to include ammonia, amines, and amides. So I hope to see you then if you need it.